Dear students, welcome to CSIR Virtual Laboratory. This is a video demonstration on an overview of hydrogen-based power generator, fuel cell. This video is presented by Fuel Cell Division, CSIR Sikri, Chennai. India is the world's third largest consumer of oil, for which the country has to depend heavily on oil imports. India's oil refining capacity is the fourth largest in the world, and the country is a major exporter of refined products. The Government of India is pursuing a roadmap to continue being the refining hub and expand its capacity with a plan through 2040. However, currently the dependence on oil imports is 80% and is expected to grow further. Another important fuel, which is natural gas, is currently 6% of the energy mix. The aim is to increase its share to 15%. As per the projections, India's energy demand could double by 2040 and electricity demand triple. When coal and oil are burned, they release particles that can pollute the air, water, and land. Some of these particles are caught and set aside, but many of them are released into the air. Burning fossil fuels also upset Earth's carbon budget, which balances the carbon in the ocean, earth, and air. Change needs to be put forward for the present energy system to eliminate the major dependence on fossil fuels and on the issue that they bring unbalance of resources, environmental pollution, and depletion of resources. There is a high demand to find alternatives for depleting non renewable energy sources. Since the world is looking forward to a zero carbon economy, it's necessary to replace non renewable energy sources with potential renewable energy sources for power generation. Generating energy that produces no greenhouse gas emissions from fossil fuels and reduces some types of air pollution. Diversifying energy supply and reducing dependence on imported fuels. The benefits of renewable energy use are less global warming, improved public health, inexhaustible energy, economic benefits, stable energy prices, reliability, and resilience. Fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. Fuel cells have several benefits over conventional combustion based technologies, currently used in many power plants and vehicles. A fuel cell consists of two electrodes, an anode and a cathode, sandwiched around an electrolyte. The anode is the electrode at which oxidation, loss of electrons, takes place. In a fuel cell, the anode is electrically negative. The anode is composed of platinum particles uniformly supported on carbon particles. The platinum acts as a catalyst, increasing the rate of the oxidation process. The anode is porous so that hydrogen can pass through it. The cathode is the electrode at which reduction, gaining of electrons takes place. In a fuel cell, the cathode is electrically positive. The cathode is composed of platinum particles uniformly supported on carbon particles. The platinum acts as a catalyst, increasing the rate of reduction process. The cathode is porous so that the oxygen can pass through it. PEM. The PEM is a thin, solid organic compound, typically the consistency of plastic wrap and about as thick as 2 to 7 sheets of paper. This membrane functions as an electrolyte, a substance that conducts charged ions, in this case protons, but does not conduct electrons. This allows the solution to conduct electricity. This membrane must be kept moist to conduct particles through it. A fuel, such as hydrogen, is fed to the anode and the air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and electrons to produce water and heat. At anode, hydrogen fuel is channeled to the anode, where the catalyst separates the hydrogen's negatively charged electrons from the positively charged protons. At PEM, the membrane allows the positively charged protons to pass through the cathode, but not the negatively charged electrons. The negatively charged electrons must flow around the membrane through an external circuit. This flow of electrons forms an electrical current. At the cathode, the negatively charged electrons and the positively charged hydrogen ions, protons, combine with oxygen to form water, H2O, and heat. Hope you all enjoyed this video. Thank you very much.